We learned there are 5 modes in NBMA in the previous sessions. We also did a lab. We tested this. You see, the broadcast type, it is okay to use even if you have partial mesh. But make sure in a partial mesh, you cancel the DR-BDR election by setting priority. If it is full mesh, it's really good. You will have a DR-BDR election. Neighbors are automatically discovered. And this type is a Cisco standard. All need to be in same subnet. The timers are 10 and 40. Same way, if you are going to use point-to-point, the timer is 10 and 40. This is also Cisco. Because it is point, wherever you see the word point, you will see no DR-BDR. You see here also point, no DR-BDR. Point, no DR-BDR. Yeah. So other than this point-to-point or point-to-multi-point, wherever you have the word point, you have no DR-BDR. The rest you all have DR-BDR. Now this is the best one for full mesh or partial mesh or any topology. Why? Because there is no DR-BDR. It is okay to have this in any topology. A non-broadcast, which is the default type on frame relay interfaces. Again, it is recommended for full mesh. If you use this mode in the partial mesh, make sure you suppress DR-BDR. And very unique behavior of this mode is manual configuration of neighbor. And this is an RFC standard. All the participant routers should be in same subnet. The timer is 30 and 120. If you have point to multi-point, again, this is RFC, same subnet. All the participating routers should be in same subnet, 30 and 120. Point to multi-point non-broadcast, again, this is unique. Neighbors need to be manually configured. Good news is there is no DR-BDR, so it can fit in any topology. If it can fit in partial mesh, it can also be used in full mesh. This is again Cisco standard. And this is what we did for last couple of sessions. We tested all this. If you have forgotten any of this, you need to go back to the previous class video. Whenever we enable OSPF, we may sometimes need to debug to troubleshoot. So it is good to know this debug command. Debug IP OSPF adjacency. This is the command ADJ. You don't have a command called adjacency. So whenever there is a change in the neighborship neighbor relationship adjacency state, whenever there is some change because of some events that occur in the network over the link, it will shoot out the things that go behind the screen, which we call as debug, behind the screen info. Normally, we cannot see all these things. You see the adjacency state, init state, and then it goes to two-way state, and then it goes to the extart state where the master-slave relationship happens. for time being in the point-to-point network. Because it's serial, no, it is point-to-point. And then the exchange state, and then the starts. After it starts is exchange state, and then loading state where it's loading, and then to the full state. And I can see even the router IDs of both the routers. This is the router ID of the local router. This is the router ID of the neighbor router. Right. Also, you can see in the same debug IPOSP adjacency in a broadcast environment. See, this one is point to point. In point to point, you will not see DR/BDR in the start state. Whereas in the broadcast, you will find the election process. After two-way, the start state begins. See, start state. In the start state, this is what happens. They all talk each other. By sending hello packet, they all talk each other, compare the router IDs and priorities based on which one of the router will be elected as the designated router. And the other one is backup designated router. Initially, BDR will be elected, and then the BDR will promote itself to DR, and then the DR will be elected. So what I'm trying to say is, the router with this router ID did not become DR directly. First, it will promote itself as BDR, and then realize that after comparing the router ID, it realizes that it can promote. There is no other router with the better router ID, big router ID. So it promotes itself as a DR, and that opens the room for the next biggest router with the router ID to declare itself as a BDR. That is what happens in the start state. And then the exchange state, and then loading state, and then full state. So in this chapter, the main focus was about the type of networks. Even the title of this chapter is Network Types in OSPF. All right, we saw point-to-point network type, broadcast network type, and then in broadcast there will be a DR/BDR election. The multicast address 224.0.0.6 is the address that we use to send the updates to the DR. And from the DR, it was 224.0.0.5 address. Right, and the router with a high priority will be preferred to become a DR during the election time, and the second highest priority will become BDR. In case if there is a tie-in priority, when you don't configure priority, the default priority will be 1. In such situation, they compare the router IDs. The one with the bigger router ID becomes the DR. The next bigger becomes the BDR. All right, and then we built a frame relay network. We saw this 5 different modes. The 5 different modes like non-broadcast, and then point to multi-point. These two are RFC standard. And followed by point to multi-point non-broadcast, broadcast, and point to point. These 3 are Cisco standard. And then at last we saw a debug command. There is also another debug command I will recommend you to use is debug IP OSPF events. This will also show you detailed hello packet information, who is sending hello to whom, all those infos. This is only adjacency. Even after forming adjacency, the hellos are sent. If you wish to see, then you need to type events. Right, so OSPF is a link state routing protocol. We all know that. OSPF is a link state routing protocol. That link state is advertised. That makes the other router to discover the whole topology, using which the shortest path first algorithm picks the best path to reach the remote destinations. But you know, there are different type of link state advertisements in OSPF. This link state advertisement is of many many types of link state advertisement. We got link state advertisement, which is within an area. Some link state advertisements go between the non-backbone area and to the backbone area, vice versa. Some link state advertisement go from one non-backbone area to another non-backbone area via a backbone area. Like, you know, you have newspapers. Some newspapers go worldwide. We call it as international newspapers. When you board a flight in the early morning, international flight, oh, you get a lot of free newspapers, international newspapers. Those newspapers are not available on ground. It's only for the flyers, especially if you're flying from continent to continent. You get the newspaper of both the continents. And those papers will not have much information about the local politics, weather. Maybe weather you will have, but not local politics, local problems. Only international problems. Where is that MH, whatever the flight has gone? Where it might be. Those type of news, international news. That Malaysian airline which disappeared. There was an alien yesterday next to Sam's house. And that alien wants to give a gift to Bala. But alien do not know the address where Bala lives. That news will not be there in the international newspaper because that is local. It will be only in the national newspaper. Maybe alien visit may be in the international newspaper, but not the gift matter. What gift an alien can give you, Bala? Alien is from somewhere. No cell phone he can give. Can he give food? No. Can he give you money? No. He's coming from some other planet. What information you are expecting from him? From the alien? What information? Tell me something, no? Oh, okay, that information. Okay. So he says, my place from where I'm coming is full of acid. No human being can live there. Only we can live. Will you go there? Definitely not. Then that information is useless for us. Anyway, just time pass. I was telling you something. But what I'm trying to say is the newspaper which I read in India, definitely you have not read today because it's not available there. Likewise, the newspaper that you read is not available here. I cannot read also because it's not available. The newspaper that someone was flying in the air in the morning, reading right now, we cannot access because it's an international news. So what I'm trying to say is you have different type of newspaper. Likewise, there are some newspapers, sorry, there are some advertisements that OSPF will send which is local within the area. For example, if that advertisement is sent by a router in area 1, it won't go to area 0. If it don't go to area 0, then it cannot go to any other area, which means that advertisement is local to that area. We are going to see different types of advertisements. Now, you may have a question in your mind. What is the use? What is the use of knowing the advertisement types? The use cases, when you know different type of advertisement and their limitations and what they carry, if you know those things, you can decide whether to allow it or deny it. That's the reason why we need to know. See, when you don't allow an advertisement from other area to come inside your area, what happens, Your area will not know about those areas. For example, the North Korean emperor do not want to allow any newspaper or the internet web pages to be available for North Koreans. What is he achieving? Nothing. He is discarding his country from the rest of the world, meaning the messages, the informations, the updates of the rest of the world is not revealed to his people. Mr. Kim, what is the benefit of you doing that? If a cat closes his eyes and say the earth is dark, is it truly dark? No, open your eye, it is not dark. Come to the reality. Likewise, if you do not want to learn routes of other area in your area, you don't want other area routes to be seen in the routing table of your area, you can block them. For that, you need to know which LSA type, which link state advertisement type brings the other area route so that you can block it. Anyway, I want to go straight into the subject now. I have given enough of it. Summary overview of this chapter. Look at this picture. One big area. 8 o'clock, right?